couple sections are like basically all your vocab words. So some of you have probably heard of these properties in Algebra 1 maybe, and then you kind of forgot about them because you didn't use them anymore, but these are properties of real numbers. So real numbers are the numbers that you guys know. We haven't discussed imaginary numbers yet, and we won't until chapter 4. So real numbers are pretty much any number that you've ever thought of, like 1 and -1, 7.2, 0.3 repeating, random decimals, random fractions, all of those are real numbers. With those real numbers, we're allowed to do certain things to them. The first thing we're allowed to do is add them in different orders. So is 2 plus 3 the same as 3 plus 2? Yeah, they're both 5. That's the commutative property of addition. It says it doesn't matter what order we add things in, right? We add whatever order, it's fine. Does that work for subtraction? No, it's completely different. 2 minus 3 and 3 minus 2 are different. You get 1, -1, not the same. So that works for addition, and it also works for multiplication, right? 2 times 3 is the same as 3 times 2. So commutative property says it doesn't matter what order we add or multiply things in. Does that apply to division? 2 divided by 3 the same as 3 divided by 2?
No.
No. Every once in a while, it might be the same. If it's like 1 divided by 1, right? And that's the same as 1 divided by 1. That's cheating, right? So it doesn't work all the time. The associative property. So the associative property says, essentially, it doesn't really matter who the numbers are associating with. We're going to get the same sum or the same product. So if I have a few numbers here, if I put parentheses here, is that the same as if I put parentheses here? Yes, because it's all addition. If I change one of those signs in there to subtraction or something, it's not going to be the same. But once it's all addition, or if it's all multiplication, it doesn't matter, right? So both of those things are the same. The identity property. So when you think of the word identity, what do you think of? Identify. Value. What about the value? Like, does the value change? Does the value stay the same?
Stays the same.
Stays the same, right? So this part of the word identity, ident means the same. That's where that prefix comes from. The identity property of addition is whatever you can do via addition that won't change that number. So if I have the number 2, what do I add to that so that 2 doesn't change?
0.
0. So the identity property of addition says when you add 0 to something, it's not going to change the number. Okay. So what would the multiplication version of that be? 1. Yeah, when you multiply a number by 1, it doesn't change the number. Mr. Identity. Okay, symmetric property. You probably use this maybe in geometry where you like flip things around, where it says like if like 2 equals x, then x equals 2. We'll use it probably more when we do inequalities. It's kind of weird sometimes when we look at this, like 2 is greater than x, right? It like makes us uncomfortable at times, so we just flip that around to x is less than 2. Like that's when we use it the most. This doesn't bother us anymore because we're in Algebra 2, but when we were in Algebra 1 it bothered us, right? And we would just flip it around. But we can do it with inequalities as well. We can switch them. Multiplication property of 0. That one's almost self-explanatory. What happens when you multiply something by 0?
0.
Every time?
Yes.
Yeah, every time. That's that property. So 2 times 0 is 0. Anything times 0 is 0. Like always. For real numbers only. Multiplication property of -1. What happens when you multiply by -1?
Becomes a negative.
What if it's already negative?
Then it becomes
Then
positive.
it's positive. So it becomes its opposite. So in math, when we use the word opposite, that means different sign, all right? So the word opposite means a lot of things. For us, it means different sign. So if it's negative, it's going to become positive, and if it's positive, it's going to become negative. So it becomes its opposite. We don't want to get the words opposite and inverse confused. Those mean different things. And inverse actually means a few different things in Algebra 2. Like, we'll use it in a number of areas. A multiplicative inverse is when you multiply by the reciprocal. Or, I'm just going to write the word reciprocal here, actually, so we can talk about it. Does anyone know what a reciprocal is?
The op. It's kinda
No,
like-
you
it's
wanna
like-
say
it's like
opposite.
flipped or something.
Yeah, it's like the
Yeah.
flipped version of itself. So the reciprocal of A would be 1 over A, right? Those would be reciprocals. So the multiplicative inverse property says 2 times its reciprocal is going to be equal to the identity number, 1. So this guy is the reciprocal. If we take a number and multiply by its reciprocal, we get 1 every time. It works for all numbers, right? So if we take 2/3 and we multiply by its reciprocal, do we get 1?
Yeah.
Yeah, because we can do this. Everything's a 1. Right? The additive inverse, so that's your multiplicative inverse. The additive inverse uses the same kind of logic. What would we do to 2 to get its identity 0? Like the identity term that we talked about over here.
The times.
Opposite of, then, opposite of 2.
The opposite of 2. So yeah, we could multiply by
Oh,
0, but we're
-2.
talking added, yeah. So we would want to add a -2. So we would want to add its opposite. So here, we're multiplying by the reciprocal. Here, we're adding its opposite. So it's important to understand all these words, like, they kind of sound the same, right? They kind of sound like the other guy. Inverse, opposite, reciprocal, and we don't want to get them confused. So opposite, different sign. Reciprocal, flippy flippy. And then inverse is kind of our universal term to mean either or, if we're talking about multiplication or addition. But we'll also use inverse for, like, we'll talk about inverse functions and stuff. That all comes like way later. Let's scroll. Any questions? So it seems like, oh, why do we need to know this? We need to know this because we need to understand that different numbers have different properties. So this is stuff we can do with real numbers. Eventually we're going to get to logarithms, or we're going to get to imaginary numbers, and these properties might not hold. You might not be able to do this. You've been able to do this because all you know is real numbers. But eventually you're going to learn about different kinds of maths that don't follow these properties. Like, we are not allowed to do all of these things with them. All right, so I'm going to pause my recording for you. Might see these words like on an SAT, ACT, in higher levels of math. You do proofs with these. So you prove, for example, like all even integers divide 2. You have to like write a proof for that. So it's important to know what these words mean, what they represent. And we're going to try to continue to talk about them. Natural numbers are the numbers that you naturally count to. So when you start counting, what do you count with?
1.
And then,
2.
and then,
3.
and then you just keep going. So your natural numbers are the numbers you naturally count to. We call those the counting numbers. Okay, no decimals, no fractions. Stuff that I'll simplify to something that you can naturally count to. And then there's one difference between a natural number and a whole number. You know what it is. It looks like this. It looks like a whole.
0.
Yeah, 0. So the difference between whole numbers and natural numbers is literally in the set of whole numbers, we're just including the number 0. So it's still all of those natural numbers, but we're including 0. I want to point out at this time, because at some point last year, like, nobody knew this, and I don't really know when you're supposed to learn this. The number 0 is not positive, and it is not negative. It is not even. It is not odd. Okay, 0 is 0. It is nothing, so it can't have a positive or a negative amount associated with it. Okay, it can't be even or odd. It is nothing. It's none. So just so you know, I pointed it out. Don't forget. Oh, I just realized I kind of put that in the wrong spot. That's okay. So these are your counting numbers and 0. Let's switch those two. Doesn't really matter. Integers. This is like the most common word I'd say often spoken about. What is an integer? What does it include that the other two don't?
Fractions.
Nope.
Negative.
Negatives. So it's all of these whole numbers and their opposites. So whole numbers and opposites. So like -2, -1, 0, 1, 2, all the way this way, all the way that way, forever, as long as we're not sticking decimal points after them. Those are your integers. These are the numbers people tend to enjoy working with. And then when we start sticking fractions and decimals, people start going, wee. Fractions are friends. All right, so if that's all the numbers that we like, these are the numbers we don't like, right? So what's a rational number?
I think that's fractions, isn't it?
Yeah, so by definition, a rational number is a ratio. See how the word ratio is in the word rational? Of 2 integers. Or it's any number that could be written as a ratio of 2 integers. So for example, 1/3. One's an integer, 3's a ratio, or 3's an integer, therefore that's a ratio of 2 integers, yes?
Yep.
What would 1/3 be as a decimal?
0.3.
0.3 repeating. Okay, so that means that 0.3 repeating is a rational number because it could be written as a ratio of 2 integers. So even though it's not looking like that right now, it doesn't make it not rational. Okay, so it's rational, it makes sense. All of these are also rational. And any terminating decimal, do you know what terminating means? Terminator. If I terminate myself, what am I doing?
Oh, it's deleting itself. Like,
Hmm?
I don't know. Explain.
I know, it's
I
a
don't
weird word.
Like clearing out.
Sure, that kind of works. So terminating decimal is any decimal that is gonna end at some point. So like stop or end, and there's not gonna be stuff after it. So yes, we can have all repeating decimals, but also any decimals that just kind of stop. So like 7.235. As long as it ends, it's rational. Now, you might not know what the fraction version of that is, but it has a fraction version of that, right? You can write it as a fraction. More simply, if you had like 0.5, you could write that as 1/2, right? Or like 5/10. Those would be easier for you to kind of do in your head, but you could do it with this guy too. It would just be irritating. All right, so if that's rational, then what's irrational? Like, there's nothing left, right? What's left?
The ones that don't end and keep on going.
The ones that don't end keep going, but don't follow a pattern. So non-terminating and no pattern. Can you think of any numbers that don't terminate?
Pi.
Yeah.
Pi.
Pi. So pi is like the one that we use a ton in geometry, but there's other ones too. This year, later on, much later on, second semester, we're going to talk about E, which is also a number. It's a letter that represents a specific number. Okay, it's a really important number. But also just like random radicals, like the square root of 5. What happens when you type that in on your calculator?
It goes to square root of
It like goes as far as it can, right? Yeah, like it'll either tell you, yeah, I'm still the square root of 5, or it'll try to give you a decimal, but eventually it's like, my calculator can't go on forever, so it has to stop at some point, but that doesn't mean that it stops. It keeps going. Now, going back to rational, the square root of 25 would be rational. Why?
Because it's 5.
Because it's 5. Because it simplifies to a ratio of 5 over 1, or 5. But irrational are going to be those like icky square roots that we don't, have. So like square root of 5, square root of 7, stuff like that. Anything like 1.2, 3, 4, 5, and then it's just going to like, if it keeps going in that order, like 6, 7, 8, 9, it's not following like a repeated pattern. It's just kind of going forever. That's irrational. And then real numbers are all of these. So they encompass all of these numbers. Okay, I'm not going to put an example. I'm just going to point to all them guys over there. Here, we're going to identify them as real, rational, irrational, integer, whole, or natural, or most, or more than one. So let's look at the number 0.
Whole number.
It's a whole number. Is it also anything else?
It's also integer.
It's also real. It's also an integer. Anything else?
Is it rational?
It is also rational. It's kind of weird to think of it as a rational number, but technically you could take 0 and put it over anything and get 0. So it could be written as a ratio to integers, just like a weird one. Anything else? No.
No.
All right, point 5.
Rational.
It's rational and real,
And that's it.
and that's it. So it's rational because we can write it as a fraction like 5/10 or 1/2. It stops, it's terminating decimal. Okay, so then what's 1/2?
Rational and real.
Yeah, same thing. So it's the same as 0.5. Just looks different. We have to see numbers in different forms sometimes. We have to look at them as fractions sometimes, and other times we have to look at them as decimals. What is 1/3 plus 1/3 plus 1/3? 1. They taught you what when you added fractions? To do what?
Add the top.
Yeah, you add the
numerator.
numerators. You add 1 plus 1 plus 1, you get 3. Put that over the denominator and this simplifies to 1, right? Okay, well what if I had 0.3 repeating? What is 0.3 repeating plus 0.3 repeating plus 0.3 repeating?
1.
Isn't it the
0.9.
same thing? So wouldn't it be 1? It bothers you, doesn't it? What do you think, what do you want to say?
0.9.
0.9 repeating. Wrong. It's 1. He's right, it's 1. It's the same thing, it has to be 1. You can't say that 1/3 and 0.3 repeating are the same and then take 3 of them, add them together and get a different number. That doesn't make sense. It's 1. But your brain doesn't really understand that. Your brain wants to say it's 0.9 repeating, which also makes sense. But that's why decimals are the devil. And we have to use fractions sometimes. Fractions are our friends. Fractions make more sense in this scenario than decimals, and that's why we sometimes have different versions of numbers. So right now, you pretty much know fractions and decimals. Later on, you're going to learn about different versions of numbers and why it makes sense to put them in one form versus another form. All right, let's look at this number. 0.121212.
Rational.
It's rational. It's essentially 0.12 repeating, right? So that's going to be rational. Any repeating number.
Real.
And it's also real.
Would every number be real?
Yeah.
Yes, every number is going to be real. So let's just go on. Real, this is real. All these are real. Because we're not going to talk about imaginary numbers until chapter 4. What about 8? What else is he other than real?
Natural.
Rational.
Natural, rational,
Whole. And integer.
whole, integer. Wow, this guy's like so many things. He's like almost all the things, basically everything except irrational. And then this random number,
Irrational.
that's our irrational number. Looks like it's kind of like following a trend, but it's not necessarily repeating. There's no repeating, there's nothing that says that it's repeating, so we're gonna have to go with irrational, like your square root of 2, square root of 5, something like that. Okay. So a coefficient is the numerical term, or the numerical value of a term. we need to know what this word means because often we'll refer to what's called the leading coefficient. Okay, a leading coefficient would be if we had a sum of terms, the leader, or the one associated with the variable with the highest degree. Don't have to necessarily stress that word too much right now, I'm just kind of looking in the future. So coefficient is that numerical term. I know the word variable is on your list of vocab words. What's a variable?
It's an undefined term.
Okay, and usually we like try to define it, so what does it look like?
Like X
X,
or
Y,
Y.
Z.
So typically a letter.
Yeah.
So a letter. And what is it like? Why do we use that a letter and not like a number?
There's a missing.
Yeah, like we don't know what it is. We're trying to figure out. So it's a letter that represents an unknown value. A constant does not have variables. So if I'm like going at a constant speed, what does that mean?
You know,
It's not changing. I'm not speeding up. I'm not slowing down. I'm going at a constant speed. A constant in math is an unchanging value. So it's any value. So like 5, it's a constant. 10, 12, negative 62, whatever. But it's not changing. It doesn't have a variable attached to it. Because once you stick a variable on it, it can change. Because that variable is representing quantities we don't know. So basically a constant is just like a number. Any real number. Done. Alright, so what we're going to do is we're going to use constants, we're going to use variables, we're going to sometimes put them together to make coefficients in front of them, variables, and write expressions. There's words involved here. Words can be intimidating. Don't look at the words and get scared. Just sift through and find the important information. Typically in math class, the numbers are very important. So it says you have $20 saved. Underline $20. I have $20 saved, and I save an additional $5 each week. So like this week I got $20. Next week I have how much? $25. Next week I have $30. All right, it's gonna keep going. It's gonna keep increasing by $5. I want to write an algebraic expression that models the total that I have. Now, it's not an equation, it's an expression, so I should not see an equal sign
So it'd be
anywhere.
5x.
So before we start using variables, what we want to do is define them. So what is x representing in your
Per week.
scenario? The weeks. So we're going to say x, or let x, equal the number of weeks, right? And you want to do something with 5x. What else do we want to do?
Plus 20.
Yeah, plus 20. Now, is it 5x plus 20, or is it 20 plus 5x?
20 plus
Doesn't matter.
5x.
Doesn't matter because,
It's a reciprocal.
The addition.
Oh, wait, no, that's
I
not.
know, you're like, what the heck was that property?
Multiplication value. Associative.
Nope, close. Commutative. That's the commutative property of addition. I know, it's so hard, like, you're like, oh, I just learned that, what was it? So that's the commutative property of addition. It says, doesn't matter, it's 5x plus 20, it's 20 plus 5x. Now the sentence kind of writes it like this, so you might think, oh yeah, it should be 20 plus 5x, but it really doesn't matter, especially when it's an expression and it's not an equation, then it really doesn't matter, because there's no like orientation of it at all. Okay, solid. All right, now, here's how a we try works. When you have these things, often you'll be asked to evaluate. This U looks weird. That means to just find the value. Okay, so if you see the word evaluate. Sometimes we'll use the word simplify. Okay, but we don't use the word solve in this scenario because solve implies we're solving for a variable. We're gonna get something like x equals 2. We're not getting that. We're not really solving an equation. We're just kind of getting all of our numbers together, and then we're gonna simplify them to like one number that's small. So the first thing we have to do is what?
Plug it in.
What's a better word for that?
Replace.
Substitute would be good.
Yeah.
Replace is good too. But yeah, so we want to substitute the x's and the y's in there. So I need to substitute 1 in here. I need to substitute 1/2 in here. So what that looks like, it looks like 1/2 plus 1/2 squared. Some of these parentheses might look unnecessary to you. I don't care, I want you to use them. Because at some point, they'll be very necessary. There's a very big difference between 1/2 squared and 1/2 squared. This looks like you're just squaring the 1 and not
Yeah.
the 2. This looks like you're squaring the 1/2. They're very different things, and if you type them in a certain type of calculator, you might get a different answer. Not ours, like our calculator is usually pretty smart, so it would do it. Like that's why we require it, 'cause it's so good. But if you're typing it in like your phone or something, or like a little, it's not gonna do it right. This is already done. How do we square a fraction?
You multiply
Multiply it by
Itself.
itself. So what's 1/2 times 1/2?
1/4.
1/4. Okay. How do we add fractions?
You have to
Make
make the
the same.
multiplier, and yeah, you have to multiply the denominator to equal the other one.
Exactly. So we have to find a common denominator. So we would multiply this by a 2, this by a 2. That would make this 2/4 and 1/4. That's gonna be
3/4.
3/4. Is this the same as this?
Yes.
Yeah, so then I don't care how you write it, if it's the same. Everyone always asks me, fractions or decimals. This is not the same as this. This is not really the same as this either, because this is confusing. So if it doesn't terminate, I want it as a fraction, okay? If it does terminate, I don't care. In some situations, you'll want it as a decimal, like if we're talking about money, are you gonna write like 1/3 of a dollar?
No.
Like who does that? That's strange. Maybe, I wonder if they do that in some countries. Do they do that in some
Do they
countries?
do that in Vietnam?
No.
No. Well, like, I don't know all the
Money's
currencies
too big
either,
already.
so
We
that'd be
use like
interesting.
thousands.
There is a half
Because we're too
penny.
poor to have big.
Half penny.
Yeah.
We have big
There's
money, we have
a-
500.
What a
we have
useless amount of
before.
currency. Yeah,
Like,
so
it's a
we don't do
lot
that.
more.
And we don't do like 3 decimal places either. We round, right? So when you go to the gas station, you'll see the price. It'll say like, I don't actually know what gas costs, like $2.49, and then sometimes there's a little 9. Have you seen that?
Yeah.
You guys might not all drive, so there'll be like little blocks, and it'll be like $2.49, and then sometimes like in the corner there'll be another 9. That's for rounding purposes, so that when you're like buying gas, if it's like more than 2 decimal places out, it'll round it up because it's 9, like jerks, right? So that's so that your total amount will be easier for them to like calculate. Because if it wasn't there, then the rounding would be rounding down sometimes, and they want your money. So, all right. So what you try is